Hello everyone and welcome to another episode of Kelly Telly. Today we're going to be talking about the types of heat transfer, following on from our video yesterday on understanding what is heat and what is temperature. Now just a little recap if you don't remember. Heat is the energy that is in all particles that exist, in anything that's made up of matter. Now these particles are always moving, and the total velocity of these particles is what we call heat. Now, temperature is a measure of the average velocity of those particles. Okay, so just a bit of a recap there. But now we're going to jump into the types of heat transfer. So this is a way that heat moves from one object to another object. So let's get started there. As we can see on this diagram, it's already giving us a little bit of a preview of the three different types there. So there are three different types of heat transfer. We're going to do them one at a time, starting with the first one, convection. So convection is probably the trickiest one to understand, but basically it can be very simply understood in this. So convection is a method of heat transfer in which hot particles rise and cool particles fall. So this is most common in air or water. So basically if you have any combination of air or water, the particles closest to a substance that's letting off heat is going to cause certain particles. So if we get our little pen out here, probably not red. These particles down here, those particles, let's just pick one, is going to heat up. Okay, when that particle heats up, it's going to gain more kinetic energy. Okay, and when it does, it's going to move away from the source of the heat. Okay, so it's going to like propel it away. As it gets up here, its temperature, the heat that the particle has is now dropped. Okay, so it's now cooler, and because of that, it is basically going to be cold at the top here, and then it's going to fall down. It's not going to fall down back because if it falls down here, it's just going to move straight back up, but it's going to then flow off to the side and then straight back down as the arrows are showing here. So the convection, the way it works is that the particles move away from the heat and they rise, and the cool particles fall. So the best way to see this in like a real life example is probably an air conditioner. So in Australia, we keep our air conditioners up the top of the roof. Not sure if many of you have seen this, but in movies and TV shows in America, their air conditioning units are on the bottom, and that is because in Australia, most of the time it is the temperature is going to be hot. So we want to get the cool air. The cool air we want to fill out the room. So if we had a little vent in the floor that had cool air, would that cool air rise up? No, it wouldn't because of convection. So what we do, we have our air conditioner up top, and it releases the cool air down and it fills out the whole room. In America, it's the opposite. It has long periods of cold, in which case this is not just America and Australia, it's usually northern and southern hemispheres, but they want to actually heat up the room more often than not. So their air conditioning units are in little vents in the ground, and it releases heat in that way, in which case it fills out the room. But basically convection works in a similar way. So that's an example there, the way AC units work. Excuse me. Now you can kind of think of convection as diffusion. So basically the hot air and cool air eventually circulate until the temperature, the average velocity of these particles, at this point will be the same. It'll basically warm up or cool down the room depending on the difference in temperature between the hot and cold room. So that's convection. I hope that was easy to understand. Let's move on to the next type, which is conduction. Now, conduction is a very simple form of heat transfer. Basically, you can think of this one as touch. So conduction is a method of heat transfer in which heat energy flows from the higher temperature substance to the lower temperature substance. I'm going to put in there, if you'll also like to put it in, by touch. by touch. Now, a very easy example here is when you put a metal spoon into a hot cup of coffee or tea, and you touch that spoon, it is going to be hot because the direct contact of the hot substance, the hot beverage, is going to be coming into contact with the spoon. And when they're touching, the heat energy, because the spoon is colder than the substance it's in, heat flows from the higher temperature substance to the lower temperature substance. So it moves from the coffee into the spoon. Conduction is what's also responsible for when you are cooking and you've got a hot plate there. If you touch that hot plate with your hand, it is going to burn you, and that is because of conduction. Because your hand is cooler than the stove, so the heat is going to transfer immediately into your hand. Okay, so that's conduction, and last one we have here is radiation. So radiation is basically best way to explain it is a method of heat transfer in which heat travels through the air as invisible waves. So the most common example you'd probably get of that is from the visible waves off a campfire. Also, if you hold your hand near a heater, when you want to warm your hands by the fire, all of these are examples of radiation. Another main example of radiation is from the sun. The sun source of radiation is what is basically responsible for keeping us all alive on Earth, which would be, a frozen planet floating in space if it weren't for the sun's energy. So the radiation from the sun is what keeps us alive. So it's a little bit obviously harder to see, but you can definitely feel the radiation energy. Okay, so those are three types of heat transfer. Last slide I want to show you is just talk about insulators and conductors. So these are things that either transfer heat easily or they don't transfer it that easily. So an object that transfers heat easily is called a conductor. And an object that prevents the transfer of heat is called an insulator. The same, this is stuff that we've talked about earlier in term 1 as well when it came to the properties of metals. We're just going to have another little bit of a look at it. So a good example of each of these. A good insulator is a thermos. So a thermos is used when you want to store a hot beverage and keep it hot, or a cold beverage and keep it cold, actually. Now, yeah, for example, if you put something that was 100 degrees, it would lose heat a lot less than if you just put it in a regular water bottle, okay? And that's, to basically maintain its heat. So heat doesn't transfer away from this easily at all. Now, I didn't really have a good example of a conductor except for some metal here. So I just got a photo of some metal that is obviously, you can see that this is the source of the heat here, and it's actually traveling up the length of this metal rod here. And so you can see that even though this part isn't touching the heated part, it is still receiving heat, and it does that. The more of a conductor it is, the easier it does that. So that's about it for today's lesson. Let me know down in the comments if you have any questions, or message me on Edmodo. This will probably finish us up for heat. I might set you a few questions for it next week, but apart from that, have a good weekend. I'll speak to you all in the next video.